Okay. Ladies and gentlemen, I placed up on the Moodle site, not one day thence, I placed up there a, oh man, that's beautiful. But I actually meant to go look at something else here. I placed up there a thing called DES2, okay? Discrete Event Simulation 2. That was a model we built together last time. Now, if you're comfortable with your version of it, you can stick with that. If you want to go get the version we'll be building atop of which we'll be building, you can go get it from the Moodle site right now and download it to your computer, because we're going to be building atop of that for today, okay? Now, please go get that as we speak here. In the meantime, I wanted to reflect on some of the things that we saw. So last time we saw discrete event modeling, or discrete event simulation is a preferred term. And I noted that this model of trauma center, one of the first models we started with in the class, is an example of that sort. This sort of modeling is characterized by defined workflows, and situations where in the workflow, your ability to progress in the workflow, to go from one node to the other, depends on resources. Your ability to go through the X-ray depends on the availability of the X-ray machine and the X-ray technician. Your ability to finish that car's assembly depends on the availability of this robot, what have you. So it depends on availability of resources of various sorts. The resources, as we'll see, might be fixed, like a procedure room, or they might be mobile, like a person, or somewhere in between, but like something that's portable. But generally, your ability to progress depends on these resources. So what you're going to have is entities, which you can kind of think of as passive agents, flowing through this system. Passive in the sense that they don't really interact with each other except in one way. And what is that one way one agent, one of these entities interacts with another? They block resources. They basically block each other because they starve each other of resources. While one is in the X-ray machine, the X-ray room, you can't come into it. While one is occupying the procedure room, you can't come there. While one robot is working on one car, another car can't be using it. So generally, they interact with each other through resources. But other than that, they're fairly passive compared to agent-based modeling. Agent-based modeling are infecting each other, spreading things from each other, competing with each other. Here, they're pretty passive typically. They come down and they flow through these processes. And along these workflows are particular processes represented. I didn't emphasize it last time, but these processes can be hierarchical. In other words, this little block here, it says CAT scan, could be expanded into a whole process itself. So you can actually, in contrast to, say, system dynamics models where it's all horizontal, you can actually have hierarchical workflows here, okay? And the ability to progress down a given one of these depends on availability of resources, and those resources are generally limited. They are limited in terms of their number and type, etc. And as we'll see, we'll learn some additional primitives here, but fundamentally we have entities flowing through processes, being processed at these stages. The flowchart specifies the process, and there's resources required for them to make progress. Entities are going to interact with resources in two ways. One of them we saw last time. Which of these did we see last time? Seized. We seized a resource and we released it at the end. In fact, we see several types of resources, nurses and doctors. Today we're going to see additionally attachment, detachment. Here, you're going to be physically attached to a resource so that when you move, that resource moves with you. Or if that resource moves, it moves you with it. Okay? So think about a doctor as a resource attaching to a person. And then when they travel, the person comes along with them. Okay? Or think about a doctor as, this time as an entity, grabbing onto a portable ultrasound machine. When they move, it comes with them. Okay? Very important, folks. This is a very important principle. There's this fundamental asymmetry here between, on the one hand, entities, these things being operated upon, and the other hand, resources. They're different sort of types of things in this model. So in an agent-based model, you might have an agent-based model with doctors and nurses and patients, and they're all just agents, and they interact with each other. You know, this patient sees this doctor, or whatever. Here, they're different sorts of things, and the entities are in some way privileged because they flow through the system and the resources operate upon them. There can be physical homes for resources that we'll see, and then we'll see movement paths defined. Okay. So the entities are the parties in which they operate. They're predominantly passive. They flow through the system. And if you want to maintain extra information, you can subclass it. In any logic, you can subclass entities, you can subclass agents, you could subclass resource types, etc. As we'll see, we're going to associate them with a physical representation, a visual representation. And they're going to have a location. Resources are required for processing. And there's generally three types of resources. Okay? One is it's going from the most passive to the least, a static resource that's fixed in location. Give me an example of a static resource. Chair. A gurney, like a bed that a patient's on. An MRI machine. A robot might be sort of static. Not in the sense it doesn't move at all, but it's fixed location. Although, I'm thinking of an assembly robot for cars. I don't think they're zipping around yet within the factory. I think they're mostly sit there and they move around their arms, but I don't think they move physically among locations. So static resources fixed. Then we're going to have portable things that get pushed. And actually, I misspoke. A gurney, a chair, those are actually portable. We can move them around, right? Just like that. So that's a portable resource. I can bring it around, but it's not like a room or a fixed robot, which I can't move. And finally, there are these mobile ones which have agency. What do I mean by something with agency? Well, it moves itself. It has some sort of intentionality to it, okay? Those are the three types of resources that we're going to be dealing with, okay? Continuing on here, and there we go. Okay. Partial. Okay. There we go. Good. Sorry, I'm just doing a backup recording here. Okay, great. Here, we're often going to have multiple types of resources at once. So before we had doctors and nurses, today we're going to introduce procedure rooms, etc. And we're going to define some resource pools. We already did last time define some resource pools, some pools of doctors and nurses, for example. And we had a well-defined start, and they kind of flowed through. And these intermediate icons, these are the building blocks out of which we built things. There's a couple big types of icons. Last time we used sources and sinks. These are places from whence what comes. What comes from here? Sources. Entities. Sinks are where they go. Sources are whence they come. Sinks are whither they go. Okay. I also noted, although I didn't really spend time in it, to note that there are selections. So you can actually have an entity go one way or the other depending on a condition. And that condition might be flipping a coin, or it might be determining what sort of entity they are, what their recent history has been, or it might be an aspect of sort of their recent characteristics and interaction with a resource. So here, these kind of split, and it's not like it goes both ways. It goes only one way, and we determine which. There's actually a something which allows it to go both ways as well, but we're not going to be covering that here. There can be delays, which represent some amount of work that has to go on, and here, a key attention for most of these are going to be resources. So the fact that there's a delay may have minor impact at that point in the process. The point is it backs things up often. So resources are required, and things will back up until they're available. So the resources are going to be at pools. You're going to seize them, and if they're not available, you're going to wait. Okay? So we're going to have seize, and it's going to seize a resource from here, use it for a certain amount of time. Seizing is really, mark my words, seizing is allocating. That's what seizing means. It allocates this thing. They may actually be at different locations right now. It's going to come back to see us. Attaching is going to depend on them being at the same location. Okay? Seizing is just, I associate this car with this robot, or this patient with this nurse, or what have you. And then we'll be releasing. Okay? And we're going to see today attaching moving to, where basically you're moving an entity to a certain location and potentially moving a resource to an entity or to a location. Okay? So again, mark my words. Seizing and releasing dictates whether an entity is reserved some resource. Attaching, detaching indicates whether they will spatially follow each other. So I might have allocated to me, a doctor, but that doesn't mean they're following me around, right? Okay, great. So I'd like to dive into this using the model that we looked at last time. So I'm going to suspend this. And let us now go to our model. So I'm going to close this one, close others. There we go. And, oh my gosh, sorry. I closed the key one. Okay. There we go. And, okay. Here we go. Okay, so this is the model we built last time. It has two types of resources, nurses and doctors. Okay, and you may recall that we seized resources for different places. Where were doctors used here? Does anyone remember? What's that? The HPD step, the history, physical, and diagnosis. The assigned nurses and release nurses are where the nurses came from. So the nurses were responsible for this. They sat through this and they finished up. And we did some experimentation where last time we emphasized one big use of discrete event modeling and made reference to others. We examined how the size of the queue, for example, and the utilization of the resource depended on the amount of resources available. We made reference to the fact that you could also look at the transit times. And in fact, we put in these time measure start, time measure end to quantify how long does it take for someone to go from one to the other. And we saw we could represent bulking. Okay. Today, we're going to elaborate this in some important additional ways that are rather central to some uses of discrete event modeling. And again, play to its strengths. Okay. Maybe I'll just ask this. This model here that we looked at, could we create that in agent-based modeling? Okay. Given how you saw this built, or given the chance to do it in agent-based modeling, which would you prefer to do it in? If you were given 2 hours, which approach would you prefer to use? And why is that? Where is kind of where's the pain point in firms that are doing it in terms of agent-based modeling?
It's all fairly complex agent interactions between messaging and holding onto each other and stuff like that.
That's right. That's right. So particularly the resource-related factors and sort of these factors of allocating and deallocating, who has this resource right now. Could you do it? Absolutely. And many of you could do that as a programming exercise, but here it's very natural, it's very transparent to do it because the operators, it's just part of the language of this. Whereas in agent-based modeling, it's really that allocation of resources isn't part of the building blocks or language we use. So ladies and gentlemen, when we think about system dynamics, we think about HBase model, we think about discrete event modeling. These are in many ways different languages for describing complex systems. They're different languages for characterizing the behavior, the dynamics. And each of them has a kind of natural sphere of application. Okay? This provides a very crisp language for characterizing structured workflows that are contingent on resources, and things like allocation, deallocation of resources are basically trivial to undertake here, with a minimal of programming. Could you undertake them with an HBase model? Yes. Could you simulate a very similar system with system dynamics modeling? You could, but in both cases it would require a lot of extra work. And what we're going to see next is layering on top of this visual representations and representations based on spatial layout, where again, doing them with either of those other approaches would start to be impracticable, or it'll be awkward. Okay, so ladies and gentlemen, I'd like you to take this model and I'd like you to save it as befits at DES3. Okay, DES3. Okay, I sense adverse air quality. Okay, great. Oh man, someone stuck gum up under this. Hopefully no one in this room. Okay, okay, so ladies and gentlemen, what we're going to do is we're going to add a new type of resource. And this resource will be different. It'll be a fixed resource, okay? So we're going to go to the palette and go to the process modeling, yes, go to the process modeling library. We're going to use actually two palettes, the other in just a moment, but we'll do this one first. And I'd like you to draw in, I stand out of order. We could do it that way, but just to make the point clear, I'm going to say new agent type, and this will be procedure row. Why would I define this as an agent? I can actually do it without defining a whole agent type. What would defining it as an agent type allow me to do?
Maybe we can collect statistics easier.
As normal, Rowan is bang on. That's exactly right. That's exactly right. We could collect information about its history, when was it in use, what was its scheduling like, who was using it, all that sort of stuff. You could do it without it, and that would actually be fine. And probably if I was short of time, I might try to do that. But showing as a resource allows us to actually accumulate lots of other information. Next, I would like to add in, as I am wont, you folks know my habits all too well these days, count procedure rooms. Okay, yeah. And what type is this? Int, indeed. And its good default value is going to be 5. Okay, next, from the palette, the process modeling library, I would like you to drag in a resource pool. And this is going to be called procedure rooms. Okay? Ooh, procedure rooms. There we go. Okay. And the capacity here is going to be defined initially to be given by count procedure rooms. Hey, come on. Count procedure rooms. Later, we're going to refine this, okay? Great. Now, what we're going to do here is we're going to go to assign nurse. And we're going to change it to assign nurse and room. Okay? So we're going to assign the room associated with the patient here as well. Remember, seizing is about allocating. Okay? This is a seize block. So guess what we have to change here?
Plus.
Sorry?
Plus.
Okay. well, we don't have to, we're going to have to change this resource set. So we're going to additionally allocate a procedure room. In both cases, we just need one, okay? And here's where the cease policy comes in. Do I seize them one by one or the whole set at once? So I wait until both are available, or is it catch as catch can? I allocate one, wait for the other. Now, it turns out that this latter one may seem desirable. You know, you get it while you're waiting for it, but what can it lead to? Anyone? Deadlock. Good. Where do you learn that? That's great. 215? 332? Yeah, it can lead to deadlock. There's certain rules of prioritization that can avoid deadlock, but if you're seizing catch as catch can, either resource, basically you could have a situation where you think about one nurse, one procedure room. This patient has the procedure room allocated, but not yet the nurse, and the other one is the nurse allocated, not yet the procedure room, and now they just wait for each other. And no one can make any progress. Glad that doesn't happen in RUH, right? Yeah. Okay, good. Okay, ladies and gentlemen, just want you to go over here to the release block, and I want you to just double check here. It says release, and notice it says all released resources of any pool, okay? So we're gonna have procedure rooms, and we have 5 procedure rooms, and we're going to try running this model right now. Okay, we'll go run it, and we will have, we'll try it with just a single, well, we should really have more than single nurses. Let's say 10 nurses, okay? And here, our ability to progress will be limited very likely by procedure rooms. So you notice, how can we tell if we look at this that procedure rooms are one of the most critical resources? Yeah, look at the utilization. Nurses are used about half the time. Only about 5 are in use at a given time. Why is that? Why only 5? 5 procedure rooms. Yeah, let's suppose we increase this to 7 procedure rooms, right? Okay, so now we're having, okay, this is kind of interesting. I would have thought that would be fine. We may have to do it from, okay, that's interesting. We may have to start it again to see that change. But in any case, here, ladies and gentlemen, the procedure rooms are, with only 5 being the bottleneck. Okay, great. But we have spaces to go. We have some distance to go. Okay, so reflect on that. We just added a new type of resource. We ran it. Doing that in agent-based modeling, again, would have been possible, but probably would require a fair bit of extra coding and sort of mechanism to do that. So very elegant ways of characterizing new resource pools and resource dependencies. Okay, now I'm going to show you something else that's quite nice. Okay, now in order to do this, we are going to go to a new area of the palette. Okay, so I'd like you to go to the palette, and I'd like you to go down to an area that's just beneath the sort of platonic shapes that you see there. It's called space markup. Okay. Next, I would like to go, and we're going to go place from the space markups a couple of things, okay? We're going to use this top space markup thing. You notice there's also GIS elements as well, which we may not get to in this class, okay? Here we go. So I just dragged down a rectangular node, and I'm going to place here a set of these rectangular nodes, and there's going to be 4 in particular, okay? I'm going to place them down here, and I'll make them a little bit smaller here so there's easily room for them. So this is going to be called procedure room 1, okay? This one here. And next, we're going to place next to it, and my own preference would be if you can sort of drag with, oh, come on. There we go. I'm holding down the control key and letting go and dragging it along. And you'll notice it's auto magically increasing the name, the number in the name. So procedure room 1, 2, 3, 4. Okay, here's procedure room 1. Hey, come on. Procedure room 1, 2, 3, 4. How did I do that? Well, I had to, in order to drag it, I needed to sort of do it on the side, and I need to hold down the arrow key and maybe the control key and do that. Not critical, but it makes it a little bit faster. Okay, here are our procedure rooms. Next, we're going to copy one of these, and we're going to make it a bigger room up here to the upper left. Okay, there we are. And this area is going to be called the waiting room. It's only going to be one of them. Okay, waiting room. And, or waiting area. Yeah, let's call it waiting area. Okay. Doesn't have to be strictly a room. Okay. Great. Okay. Next, I'd like to go create one more. And that's going to be over here, and that's going to be, actually two more, sorry. This is going to be nurses. It's going to be called staff lounge. Just one. Okay, we'll do it. Staff lounge. Okay? This is going to be where the docs and nurses go when they're not seeing patients. They'll be able to grab a bite to eat, etc. Okay? Great. So now we have these components, and we could have drawn them in greater detail there before. Next, ladies and gentlemen, we are going to go drag in this sort of a node here that's called a path, okay? And for this path, we're going to use it to delineate paths between spaces here, okay? Now, like normally in any logic, you can have some flexibility by adjusting these handles, okay? And what I'm going to do here is define a path that extends over like this, and then I'm going to drag a few more paths in here, which are going to go to certain destinations, okay? And they're going to need to intercept with a green intersection. Now, ladies and gentlemen, in order to add these handles or delete them, you just double click on them. Okay, so here's the path up. If you want to shape it, you could add one and kind of move it around. But do it like that. And now I'm going to add some short segments, which are just going to connect the edge of this, make sure it's green, to the path. So I'm going to go over here, connect this guy up there, boom. Oh man, okay. So I was hoping that this guy could be mounted here. Okay, there we go. And then we want to really bring this guy round. Okay, there we go. Okay. Yep, and I'll get rid of this guy, get rid of that guy. Okay. So what I've just done is to connect these. And these are not merely visual elements. It used to be in any logic you'd need visual elements for these, but these are actually logical paths and sort of routes. So it actually knows to connect them. If two things are connected, it knows you can go from one to the other. And it will actually perform routing algorithms on these. Okay. Similarly, we're going to do it for the others. Now, you'll notice, ladies and gentlemen, if one trick for crafting these, bending them to your will, if you just want to create a straight path, I really should have shown it earlier. Just leave these two final ones there. You can get rid of these guys, and now you have a nice little path that's a straight shot, and you could just, oh man, okay, get over there. Okay, there we go. Excellent, and you could copy them. Yeah, you could duplicate them like that, right? Oop, hey, come on, stop that. Hey, come on. Okay. 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 Hey. Oh man. Okay, there we are. Get over there. Okay. Yeah, there we go. Okay. So now, ladies and gentlemen, we have these procedure rooms defined, and we have routing that can go from them to each other. It's still going to be a little bit artificial because in order to go to this room, someone's going to have to come down like this and go over there. So maybe I'll put one more path, from this place, and I'll sort of eliminate. Oh, come on. I should have dragged it. Okay, here we go. Come on. Boom. Okay, fair enough. So this is the staff lounge. This is the waiting area, and these are successive procedure rooms. Okay. Okay. So we're in good shape. Now, do you folks want a few more minutes? Yeah, I know. It's kind of painful to wrestle those things, isn't it? Yeah, I know. So again, the pointer here is if you want a straight line, just use these bottom two. You can get rid of these upper two and just use the bottom ones, and that works pretty well. These guys here are a straight shot. Similarly, you can use different segments of it if you want curved or non-curved. Okay, who wants a bit more time? Okay? Okay, ladies and gentlemen, what we're going to be adding here is spatial layout. Spatial layout is not just a toy. It's not just eye candy. What it's going to allow us to do, mark my words, is endogenize travel time. What do I mean by that? Fancy words. What do I mean by endogenize travel time?
Oh, instead of we're going to tell the model what oh no, we're not going to tell the model.
We're not going to, it's going to tell us. Good, exactly right. So the idea here is that the travel time will be an emergent property of the speed of the agent, the location of the resources. It won't be something we program into the model that it takes this amount of time to go from the staff lounge to procedure room 4 or something like that. Rather, it's going to be telling that to us as it simulates as an emergent feature of the situation. And in fact, more sophisticated versions of this would even take into account pedestrian movement, the fact that I can't get there because there's someone ahead of me, so I have to wait for this person ahead of me to go in a wheelchair or what have you, in which case it will allow you to understand better how quickly, how efficiently, and how long certain things will take as an emergent feature of the layout, of the congestion level, etc. That's significant because it allows us to ask what-if questions about where we place things. Okay, ladies and gentlemen, next, what I'd like to do here is to go. I would like to set the visual locations associated with the resources. So for nurses here, gosh, I'm tempted to. Well, fine. We'll say nurses here, and the nurses are going to have a home location. Do you see it? It says home location associated with the nurse resource pool. There's a home location, and we're going to set it to be the staff room. Okay, let's get rid of that. I said procedure room, but I want it to be the staff room, staff lounge. Okay, staff lounge, ladies and gentlemen. Similarly, doctors will, for now, also go to the staff lounge. You could examine the impact if nurses had to be further away. Okay. Next, for the procedure rooms. Yeah, I know. I share your sentiment. Okay. No. I know those are twisty things. Okay, for the procedure rooms here, ladies and gentlemen, we are going to actually have the capacity defined here by home location. Okay. And you're going to uncheck defined by attractors, based on attractors. Okay.
What does that mean?
So there are these constructs over here called attractors. Can you see them in the palette? And those attractors can be used to indicate certain key locations to which, say, agents will converge or what have you. And so you can define attractors that are associated with a home location for a resource and dictate its capacity based on those attractors. Okay. So now what I'd like to do is I'd like to do see home locations. You're going to do plus here, and you're going to choose procedure room 1, procedure room 2, procedure room 3, and procedure room 4. Okay?
Should we be changing the resource unit to be procedure rooms?
Good call. Thank you.
In advance as well?
So if you change it at the top here, the new resource unit, Alex,
Yeah.
if you change this to be procedure rooms,
It changes it.
then it should change it down in advanced as well to procedure room. Okay? Good call. Okay. Now you'll notice something here which doesn't really make sense. Here, ladies and gentlemen, there's a speed. That's not going to make sense for procedure rooms. Procedure rooms exhibit low speed. But doctors, ladies and gentlemen, are going to proceed at not 10 meters a second, which would be a frightful apparition indeed, but 1 meter per second. So I clicked on Doctor Resource Pool and I changed it to 1 meter per second. And I'm going to click on nurses and we're going to set that to 1 meter per second as well. So doctors and nurses are going to move around, okay? And then, well, we're going to come to this might as well do it right now. So, ladies and gentlemen, I'd like you to go to the patient class here. The patient class over in the hierarchy. And for the patient, I'd like to set its initial speed to be actually uniform between 0.4 and 1.0 meters per second. So some patients may be in a wheelchair, they need a little bit more time to get around, maybe on crutches. So we'll have the fact they can be slower for some patients. This is going to be relevant because sometimes nurses will have to accompany a patient. And then they'll have to go at the speed of the patient. Okay. Okay, ladies and gentlemen. So imagine capturing that, in an agent-based model. You could, yes, okay. Okay. Finally, we are going to associate here several elements of the building blocks here with elements visually. So, ladies and gentlemen, the departure, the sink here, okay, associated with the sink, we are going to set it so that the node associated with it, and okay, I am confused because I would have thought that there'd be a node right associated with that. Okay, we'll have to come back to that here. Let's go over to the walk-in. Okay, so go to walk-in here. This is a source for the walk-in. For the location of arrival here, we are going to set it to be, and I'm going to actually place an attractor on. You notice we could search it here. I'm going to place an attractor which is going to specify where they come in. And I'm going to place it at the top of the waiting room here, okay? And actually I'm going to orient it downwards here, okay? And here what we're going to do is, so this will be called entry and exit attractor, okay? Next, the walk-in here, we are going to associate it for the location of arrival with the attractor. And what attractor? The entry and exit attractor. So we're going to have people come in at that place, okay? Next, having done that, we are going to go to the assign nurse and room. And it may be that we should have actually just used the room as a whole, but we'll see the effect that comes of that. For assign nurse and room, I would like to do the following. So you'll notice that in the assign nurse and room, we have a bunch of choices. And one of them here is send seized resources. Do you see that? It's a check mark. It's a checkbox. So we're going to say yes, and it's going to say, where do I send them? Whither do I send them? We're going to send them to the entity, okay? We're going to send them to pick up the agent, okay? And further, ladies and gentlemen, we should attach seized resources, okay? And the agent location here, when they're there, is going to be in, guess what? The waiting area. We okay with that? Okay, can we run it? We've done a lot. We're not yet done, but I just want to make sure we're cooking with gas. Now, by the air quality, it smells like we are cooking with gas. Okay. Okay, ladies and gentlemen, here we actually have a nurse who is picking up, and I'm not sure why this nurse is exhibiting unusual behavior. He's going back and forth to the patient there. Okay, sometimes the nurse is in the staff lounge, but sometimes they are proceeding to the patient. Okay, the patient is meanwhile resting in the attractor. Let's actually have them. Let's actually have the location of arrival be specified by the network GIS node, and we'll have them actually appear in the waiting area. Okay, we could do it. We could have them proceed. The problem is that it'll just be a little bit more mechanism to have them proceed directly from that node. We could put in an extra link. So I changed it so that they basically are going not to the attractor, but to that node. And okay, now that's interesting. Because the attractor is still there, they're still waiting there. Yeah. Let's take out the attractor here, so that the attractor will no longer attract them. And now let's run it. I was hoping that we would use the attractor for some additional things. Now they're filling up the waiting room. Do you see them? They look at various stages of discomfort. Okay. Okay, so here the nurses come between them. Why is that? Why is he just waiting in that room? Well, because we haven't told the nurse to go anywhere after that. And it's to that purpose that we now bend our attention. Okay? Ladies and gentlemen, I'd like you next to go to the release block. And we are going to, in the release block, for moving resources, we want them to return to their home location. Okay, we just want to make sure that that's set. Okay, great. Now, now what we're going to do is we are going to go to the initial workup. Okay, so here for the initial workup for this nurse, okay, we are going to set the agent location here. We want the agent to go to a certain location. Where do we want them to go to? To a free procedure room. Now, where's the procedure room that they've been allocated? Let me ask the trick question. Is it procedure room 1, 2, 3, or 4?
Number 1.
Well, okay, that's a nice hypothesis. That's procedure room 1. Okay, let's see what happens if we say that. So we're going to say that they go to procedure room 1. What do you think is going to happen here? Well, they're going to procedure room 1. But look, they're all only using procedure room 1, right? Remember, each of those patients has been assigned a procedure room. That procedure room is associated with them. It's been allocated to them. Where has it been allocated? Right here. It's a resource allocated to them. Okay? We need them to go to that procedure room. And right now, we can only specify agent location to be a fixed thing. So what we need to do is actually insert a new block. Okay? So I'd like you to create some space, move it around. We're going to put a little bit more space here, and we are going to drag in a new type of block. To wit, we're going to drag in from the process modeling library a move to block. Move to. And this will be called move to procedure room. They are going to be moved to their location, okay? And you'll notice here that, so the move to was down here just below assembler, okay? Don't worry, it's not assembler language, but it's moved to, so we'll move them over there, okay? Now the destination here is what? Yeah, it's the seized resource unit. And what unit? The procedure room associated with them. So we're going to move them to whatever resource unit they have been assigned. Notice we could say whether they're engaged in straight movement, and you'll notice that we can also set the agent speed explicitly for this segment or what have you. So if they're in a place which requires them to be brought around in a bed, for example, we can allocate them in a bed. Okay, so ladies and gentlemen, now what we have is we have people. They're appearing in pairs here. Okay, let's go see here. We brought them to that room. We no longer want them to this move to procedure room, this assigned nurse in room. We no longer want them to go to a specific procedure room there. We want them to be in the waiting area. For the initial workup, we had previously said go to the procedure room, and instead we want to leave this blank. Okay, so we want to get rid of this. Okay, we don't want to specify anything. Oh, come on. Okay. Okay. How do we tell it? Hey, don't do that. And okay. Can you see a way to X this out? I mean, if you go like this, you can blank it out, but that's the value editor. Okay, we'll try that. Okay. I would have thought it would allow you to unchoose it. Okay, here we go. so now when we run it, what we're going to see is, oh, okay, well, that's interesting. Let's slow this down. Okay, they are actually not appearing there, and I think it's because it is sort of overridden. Okay, it does have this. They were moved to the procedure room here. They were moved to their associated procedure room. And here at time of release, they get moved to back to their home location. The other things get moved back to their home location. But we should have the patient move to the destination here. And if we can't specify it directly at the sink, we will have to put in place a node so that we can specify it, okay? So here, let's try this. We're going to put here an intermediate node that will be called move to exit. Here we go. There we go. And I'm going to connect this. Oh, sorry. What am I doing? Hey, come on, get back there. Oh man. Okay, come on. Okay, move to exit. Here we go. The problem is that these two guys have to be connected with him. There we are. Boom. There we are. Move to exit. So move to exit will move the person to the exit. Okay. So here we go. Move to exit. And we will say, okay, we want to move it to the entry and exit. So we're going to have them move to the waiting area for now. Okay, waiting area before they disappear. Okay. So move to exit. Now for the HBD, the doctor has to get involved too. So for the HPD, we are going to send the seized resources to the agent, wherever the agent is. And once they're done, they return to their home location. Okay? Okay. So let's review this. Here we have at first, they come into the system. Coming into the system, they go to the waiting area at this network GIS node. Coming here, they're assigned a nurse in room, and the nurse that's assigned to them moves to the agent, okay? And it's attached to the agent. Next, we have the move to procedure room, where the agent, the entity, is moved to the procedure room associated with them. Okay. Next, for the initial workup, the agent location is left empty here. They are there for several minutes, for a number of minutes, and this says restore agent location on exit. Actually, that may be the problem. This initial workup, we do not want to restore the agent location on exit from here because they're just remaining there. The HPD, here we are going to send the seized resource, namely the doctors, to the agent. Final steps. Oh, okay, sorry, we should make sure with that. We don't want to do restore agent location on exit. We want to leave them. So for none of those should those be actually checked, this restore agent location on exit. Yeah. This one, it should also not be checked. Okay, good. Okay, sorry. This one, I left it checked as well. So move to procedure room. We don't want to restore the agent location on exit there. Move to procedure room. should not have restore agent location on exit. None of them should that we're using. For the final steps here, we also want to uncheck restore agent location on exit. Okay. Release should go and have the moving resource return to its location. The same thing should have been true with HPD, where the doctor returns to their location. Move to exit. For this one, we have the movement here being moved to the waiting area, and then in this one, they're just going to be leaving the system, so they'll disappear. So here we go. We're going to run this now, and here we have agents. Okay, now the nurse is moving here. What I don't see is the agents in the procedure room, which is troubling me. I don't understand why we're not at least briefly seeing the agents in the procedure rooms here.
You have the procedure rooms specified as a looping agent, so the procedure rooms.
Oh, did I?
Yeah.
Oh my gosh. Okay, thank you for catching that. Oh my gosh. Static. Okay. Capacity defined. How did that happen? Okay. Capacity defined by home location here. Okay. That's weird. Thank you very much for catching that. That's much appreciated. Okay, by home location. Yep. That's weird. Okay. Okay. So let's try that. So the procedure rooms were actually moving. There we go. Yep. Good. Okay. So the nurses and the doctors are only very fleetingly in the staff room here. Let's go check out if we have 10 nurses, for example. We should see some being sort of waiting at any one time in the staff area, right? Here's various nurses waiting there, and they're, awaiting patients. If we go and we look at, okay, so I see. We actually did not yesterday define a doctor. We have a doctor's type, but we actually don't have a representation visually of doctors. This is just a this resource pool is just of agents. So let's add in to our model, just to complete it visually. Let's add in a doctor type. So this would be doctor, and we will go and place in the palette. We will go and place a visual representation of a doctor there, and maybe we'll make the doctor a little bit bigger, making it scale 2, so it's very visually distinctive. Here we go. Okay, and now we should be able to see. Now we'll go and go to main, and we'll go to the doctor's resource pool, and we will set this to have a new resource unit called doctor. So instead of just being agent, it'll be doctor. Okay, so let me try that again, doctor. Okay.
Quick question.
Yes.
You have count procedure rooms.
Yeah.
5, but you have 4.
We're no longer going to be using that.
Okay.
So here's the doctor. You could see the doctor's presence. When she's present, you could really see it. So thanks. We'll delete this. That was only initially we were using that. So ladies and gentlemen, now we have the doctor, and the doctor is also going back and forth to the staff lounge. So they're being allocated, and they're using these procedure rooms, right? So here you are, and right now, all that's going on is that we are, we're allocating procedure rooms, and doctor's availability is the key resource. Actually, sorry, no, nurse is the key resource. There's only one nurse. If we had, let's create one more scenario here. Oh, no, not a class. New experiment, and we're going to have, 4 nurses, right? 4 nurses, and I'm conscious of the time. I'll let you go in just a second here. We're going to have 4 nurses and 1 doctor, okay? There we go. 4 nurses and 1 doctor. Now we're going to be able to have patients waiting in these procedure rooms as the doctor is circulating. You'll notice what's happening is basically the patients and nurses are going to these procedure rooms and the doctor is seeing each for brief periods of time. So here the doctor is the maxed out resource. The nurses are at 84%. The procedure rooms are about 80%. And the bottleneck here is really the doctor. And if we increase the number of doctors, we should see a commensurate, very significant increase actually in the throughput of this system, and a decrease in the time sort of in the system. So here we have a time with 2 doctors of about 3.3 hours or so, or 3.2. If we went back to a single doctor, we might have something like, okay, now we have just 1 doctor, and I'll run it forward. Yeah, it's risen to about it's going upwards of 4 now. So here, okay, and yeah, it's maxed out here. So here we have procedure rooms represented. One nice advantage of this, and this will be my final comment here, is that by so doing, we could examine the impact, for example, of different layouts of the facility. So, for example, we could go and ask, okay, what would be the advantage not only of adding another procedure room, that would be easily done enough, but of a distant staff lounge compared to a close staff lounge. And what's going on is that actually it's computing endogenously. It's computing as part of the model the travel time. It's computing how long do they spend traveling, how long does it take them to get from one area to another, etc. And for patient classes, if patients are slower, it may take longer to navigate in the area. So these are flexibilities that we can explore within this sort of modeling, in addition to having a representation of what's going on that can be fairly visually compelling when it's done right. Okay, we could do more experiments, but that's all we have time for here. And I would just ask you at home, one thing that you could do is you could ask what would be the impact on facility time and facility, so the average time there, if we had patients who traveled more slowly. So if we were incorporating patients who are on the slower side, how would that slow things down? Or similarly, if the doctors were traveling in a more slow way. But this gives some idea about how the physical layout of a facility ends up impacting the flow of patients through the facility or flow of cars through an assembly line, and allows us to quantify statistics where the movement is all endogenized. The movement is produced by the model rather than being specified to the model, and it's produced based on the path lengths and everything. Okay, that's all for today. Thank you very much, and good luck on problem set 4. Okay. Oh, I will hold office hours now.